Hi, and welcome to Day 2 Operations with Google Cloud Infrastructure. Today we're going to talk about VM Manager, Manage Instance Groups, and Recommendations. I am Sergey Maximov, Product Manager for Google Cloud. I'm going to cover VM Manager and OS management at scale. Dan is going to join me to cover Manage Instance Groups and Active Assist. Managing security compliance for large VM fleets can be often complex. In addition to existing tools, may not keep up with the dynamic nature of the cloud deployments. We designed VM Manager to protect and secure your VMs at scale. VM Manager has three key components. The first one, OS Inventory, provides you visibility on what is running inside of your VMs. OS details, installed and available updates, OS vulnerabilities, and applications. OS Patch is orchestrating OS updates at scale and for 100 VMs at a time. The third component, OS configuration management, keeps OS in a desired state. For example, make sure that all VMs have security agents installed and running across the fleet. It is going to report all non-compliant instances and optionally fix the configuration drift. First of all, let's take a look on how VM management is working. VM Manager is an agent-based system. For agent-based systems, the first step is how to get an agent installed for all VMs. We solve this problem for GCE images and pre-installed agent for both Linux and Windows. If you build your own images, we suggest using GCE images as a base image for your own process. Now agents are ready, and all you need is to activate API and allow agent to communicate with VM Manager. I want to highlight you have a full control to enable or disable agents at any time. Our agent is fully open sourced for transparency and passed multiple independent security audits. Now, let's take a look at each component. OS Inventory. Once agents are enabled, OS Inventory starts collecting data on what is running inside of your VMs. OS Inventory contains data on operating system details like name and version, open OS vulnerabilities, available and installed updates, and applications. We also send this data to Cloud Asset Inventory, BigQuery, and Security Command Center. These Google products provide a centralized organization-wide view on your environments. Patch management. Patch management reports patch compliance for both Windows and Linux VMs. You can create ad hoc or scheduled patch deployments for hundreds of VMs at a time. And you have full control over the patching process with pre and post patch automation hooks, rate controls, monitoring metrics and alerts, flexible maintenance windows. You can customize the process for your organizational needs. Configuration management keeps OS in a desired state according to declarative OS policies. For example, configuration management can deploy and maintain security agents across the fleet. It is going to report all non-compliant instances without running security agent, and optionally, it can enforce configuration and fix the drift. The best way to learn more about VM Manager is to try it for your own projects. You can find VM Manager right under Compute Engine. The first product you are going to see is Patch Management. The dashboard will show you patch compliance and scale. And you can drill down to details for individual VMs. Then you can start a new patch deployment, and the wizard will guide you through the process. Configuration management is next to it. First of all, you're going to see the state for all VMs. As a quick start, I suggest downloading your first policy from our templates catalog. I recommend to use CloudOps Monitoring Agent policy to try first. And then click Create a Policy Assignment to start your deployment process.
Thanks, Sergey. And what a great demo. Now we're going to pivot and talk a little bit about managed instance groups. Managed instance groups are for when you're using virtual machines in Google Cloud and you want the ability to scale those machines up or down or control the number of versions of those VMs that you need. We offer two different types of managed instance groups: stateless for web serving and stateful for those highly available, non-horizontally scalable VMs where you're trying to preserve state. The most typical example of this is a database cluster where adding or removing nodes requires sharding. When running these types of workloads, there are three key challenges that customers need to overcome. First is reliability. How do you ensure high availability of your workload and make them resilient to failures of an application or virtual machines, or even a failure of the entire zone? Secondly, cost efficiency is important. How do you choose the size of the VM and how many instances you need to meet that ever-changing demand from your customers? How do you identify what resources are bigger than necessary, or even which ones you've forgotten about or are idle? The third category is operations. How do you keep your application optimized and up to date with while minimizing your manual work? You can address these challenges by deploying your workload using managed instance groups, or MIGs for short. An instance group is a collection of virtual machines running a single application. With this, you get high availability thanks to our auto healing for failed instances and serving your application from multiple availability zones by a regional group. You get scalability by using fully managed auto scaling. You can safely roll out updates with orchestration provided by our auto updater. Even if you have a stateful application such as a database or a legacy application, you can benefit from auto healing as well as auto update, which will preserve the state of each individual machine in a cluster. The ability to support your stateful workloads is a big differentiator for us, as you can improve your availability and automate those updates while preserving your state. When creating a MIG, the default is a zonal MIG, which is great for restarting your VMs and other simple things, or even your complicated reliability scenarios where the specific zone is important for, say, storage or storage latency. When designing for high availability, though, you can make your application resilient for zone level failures by deploying it as a regional managed instance group. Regional managed instance groups spread the instance evenly across multiple zones in the region. Should one zone fail, the instances in the other zones will keep serving. The load balancer stops sending traffic to the failed zone and will distribute the requests among the remaining healthy zones. Next, let's talk about scalability. MIGs include auto scaling as a way for you to dynamically change the number of VMs in the group and handle the load. It creates new instances when demand is growing and deletes VMs after the load goes down. This way, you only pay for the capacity you need while you always have a sufficient number of VMs to handle a spike in load. You can auto scale based on load measured from CPU utilization, requests coming from your load balancer, or even your own custom metrics that you've configured in Cloud Monitoring. Let me share with you the new auto scaling features we just launched, which include predictive auto scaling. By predicting and forecasting the future, we can start creating VMs ahead of the load and make sure you always have enough serving capacity. For example, if it takes 5 minutes for your VM to boot and start your application, then the predictive autoscaler will create VMs 5 minutes ahead of the load, so your app is ready to handle the new demand before the demand is there. Predictive autoscaling uses Google's machine learning model based on the historical load of your specific application to predict the future demand and improve your application reliability. Now, what if your demand cannot be predicted based on history? We have scheduled-based autoscaling to help with that. Scheduled-based autoscaling lets you define periods when you want your autoscaler to maintain a minimum number of VMs that you specify. This works with regular autoscaling, which reacts to load, So if your demand capacity is higher than what you even scheduled for, the autoscaler will step in and create additional capacity to ensure you have enough VMs to handle that load. Customers use uh, autoscaling based on a schedule to spin up new VMs ahead of their anticipated spike. Like if you have a business hour application and you know that every morning your customers or your internal employees are going to come in, and you want to make sure that that capacity is there. You can also use this to create a specific one-time special event, like a promo or a campaign or even a product launch. Finally, we have launched scaling controls, which allow you to control the rate in which Autoscaler deletes virtual machines. Normally, Autoscaler removes all of the unused capacity all at once. If you want to throttle your scale and rate, you can now define how many VMs you'd like to have Autoscaler remove for a given amount of time. This improves reliability for your application, especially those applications that take a long time to initialize and don't scale out fast enough to handle a variable load. Now we're going to talk a little bit about recommendations. Recommendations is part of our Active Assist portfolio, which covers recommendations in cost, security, performance, reliability, manageability, and even sustainability. These recommendations are AI and ML-based recommendations that are specific to your project and based on what your project's actually doing at the time. So for example, if there's opportunities to optimize your VM sizes by choosing a different VM size to improve performance or a smaller VM size to improve cost optimization, our Active Assist recommendations will make that recommendation to you so you can review and take action. But it's a lot easier to show you this than it is to just talk about it. So let's do a demo.
Cloud recommendations are available throughout the console in a variety of locations. If you want to see all of your recommendations in a single location, we recommend the use of Recommendations Hub. To access Recommendations Hub, click on the menu at the top and go to Home. Once Home loads, you can click the Recommendations tab and it will load the Recommendations Hub. Inside the Recommendations Hub, you will see all of the recommendation cards that we have for a specific project. In this project, you can see that we have 4,242 excess permissions recommendations for us to review. If we wanted to check a different project, we can click the project picker at the top, switch to the other project, and you will see that it will refresh with the cards specific to the new project. Here there are 5 cards with recommendations ranging from cost savings, excess permissions, to recommendations that increase our security. Find the recommendation card that you are most interested in and click View All. This will load a screen that shows you all of the recommendations specific to that type of recommendation. Here you can see that we have a table that is sorted by the estimated savings from each recommendation.
Okay, so that's it for us today. But if you want to learn more, we have several links available for VM Manager, managed instance groups, or even our recommendations. Please feel free to navigate any of these links to get started using them today. I also want to say thank you to Sergey for joining me today, and I hope that all of you enjoy the rest of the next conference. Thank you.